It is based on diffusion. So can you tell me how to solve? At least tell me the process. Okay. Yeah. Okay. So can you tell me the final answer? What will be the equation energy for diffusion? Prakash and Achanta. Please also you people try. We know this equation. D equal to D0 exponential minus EQ by RT, where EQ is activation energy in joule per mole, T is our temperature, it is supposed in Kelvin, SI unit if we are writing, and R joule per mole Kelvin, and D this is meter square per second. So can you solve what is the activation energy? Yeah. Yes. Prakash and Rachanta, please use try. Here what will we do? The diffusivity of carbon in gamma iron at 1173 and 1273 Kelvin are given. So D 1173 is 5.9 into 10 to the power of minus 12 meter square per second, and similarly it is given for 1273 Kelvin 1.94 into 10 to the power of minus 11 meter square per second. So we will put simply value D0 exponential minus EQ. We have to calculate this EQ. R we know it is gas constant 1173. Similarly, we will write for this one. It is 1273 Kelvin. So this is our equation 1 and this is equation 2. So if we divide it, we will get 3.04 into 10 to the power of minus 1 equal to D will cancel out, D naught will be cancelled out, and it will be E minus Q by R 1 by 1173 minus 1 by 1273. So can you tell me what will be the value of EQ? Prakash and Achanta. R it is gas constant 8.314 you can write. This value is in joule per mole Kelvin. Take simply ln both sides, natural log minus EQ by R into 6.6968 to 10 to the power of minus 5. and natural log ln, this value will be equal to minus 1.07. So from here you can get EQ value. Can you tell me what will be the EQ value? It was coming nearly 147, right? 147 point something. So it is asking in kilojoule, so we will convert. Is there any issue? Prakash, or should we move to next question? Achanta, is it okay? Okay. So based on this same data, can you tell me what is the diffusivity of carbon in gamma iron at 1373 Kelvin? How will we calculate diffusivity of carbon at 1373 Kelvin? Yes, constant value, diffusivity constant. So we know already these two equations, and from these two equations we know EQ value, and for a if we put this EQ value in equation 1 or 2, from here we can find out D naught value, and from D, if we know D naught value, we can easily calculate D value because we already know EQ value. So can you tell me what is the D naught value? Okay. Prakash and Chandra, please you try also. You may write down in chat box also. I am reading. So can you solve now? What is the D naught value here? I have put in equation 1 here. Are you guys getting same value? Is it okay? So now we can calculate diffusivity of carbon at 1373 Kelvin. What will be this value? It will be like 5.3, 5.4. Here we have options. So in options, this value is given. So this will be the right answer. You check again. Is it okay? I have removed the options intentionally. Okay. So do you know what is this carburization depth? Can you tell me for the same data? Can you solve question number 73? Here we have to find carburization case depth of D. During the carburization of a steel, a case depth of D has been obtained in 40 hours. Timing is 1173 Kelvin. And for achieving same depth D by 2 at 1273 Kelvin, what is the time required? Can you guys tell me how to solve? I have taken this question mainly for this one. Yes. Okay. So can you calculate? Can you try? Yeah. Is it visible? Oh. What are you saying? Uh, T value. What is the T value? Time. Okay, okay. Please. You note down this diffusivity of carbon in gamma. Yes, yes. Have you noted down, Asanta? See, we know this equation x square equal to dt, and so here we have to calculate time. Here case depth is given, d is given. it will be dt when time is 40 hours at 1173 Kelvin. This is this x. So d 1173, what is the value? 5.9 into 10. 5.9 into 10 to the minus 12 into 40 hours. And when it is d by 2, and it is asking 1273, 1.94, 1.94 into 10 minus 11. So we have two equations, minus 11. Okay. So if we take 1 by 2, if we divide, what will we get? 2 40 by t into 5.9 into 10 to the power minus 12 divided by 1.94 into 10 to the power minus 11. So simply 4 equal to 40 by t into 0.3041. So t value will be 3.04, means nearly 3 hours. Is it okay? Achanta, have you got? Okay. See, do you guys know this fixed law, right? Second fixed law. Wait, let me solve this. Suppose this is rod and this is C0, initial concentration. I want to prove this equation, right? How to prove? X C0 is given initial concentration, and suppose surface concentration is Cs. So we know from the fixed law dc by second fixed law, flux equation dt t del square c by del x square. You know this equation, right? Here d is, it is independent of concentration as well as space. Suppose space, if we denote by x, so it is not a function of concentration in space. So what will we do? C is a function of, suppose, xt a minus b. This is error function x by 2 square root of dt. And we know error function z. In question it will be given, so there is no need to mark up this equation. Where neta is x by 2 square root of dt. So, and we also know error function 0 is equal to 0 and error function 1 equal to 1 and error function 0.5 equal to 0.5. So here we have to calculate a and b value. What will be the a and b value? When x is 0, means at here after time t, what will be the value of this Can you tell me? If we put x equal to 0 and after time t the concentration becomes Cs after carbonization, a minus b, but if you put x value it will be error function 0. Error function 0 means we know 0, so it will be only a, right? Are you getting? So uh, a, and we know it is surface concentration, we can write Cs. Similarly you can write when time is 0, what is the concentration of the rod? Initial concentration, it is C0, and if you put in this equation you will get a minus b, because when you put t equal to 0 it will be error function infinite, and we know this uh, value, so it will be a minus b. So from these two equation, suppose this is equation 1 and equation 2, you can calculate b value. What will be the b value? You may get question based on this. This is carbonization problem. I will give some question based on this. So can you tell me what is the b value? We know a equal to cs and a minus b equal to c naught, so b value will be in term of c naught and cs. Can you tell me? It will be like simply yeah, a minus c naught, and we already know a means it is cs minus c0. Are you getting it till now? Okay. And we know this. Here we simply will write value of A and B. Value of A is CS and value of B is CS minus C naught, and it is error function x by 2 square root of dt. So what will we do? We will subtract C0 both sides, and if we take a common CS minus C0 here, we can write down CS minus C0 1 minus error function x by 2 dt. Till now is it okay? Is it visible, right? Hello. Okay. So this term, what is this? This is we can find out solute concentration at different location. We can say different depth and different time, different location and different time. So here carbonide case depth is asking. So it can be defined as the depth corresponding to concentration, that is average of initial and saturated carbon concentration. So CXP, suppose this is concentration case depth, it is C0 plus CS by 2. It is just from definition. This is carbonized case depth. And already we know CXT equal to Cs plus C0 minus Cs error function x by 2 square root of dt, and this value we know, this value we can put, this is right case there. So can you solve now? Cs plus C0 by 2, can you prove this equation? In term of xp, can you find out? This will be cancelled out, so it will be 1 by 2, this is 1 by 2, and we know error function 0.5 equal to 0.5 means 1 by 2, so we can write also this one 0. Error function 0.5. So if we compare, we will find out xp equal to 2 square root of dt, that will be equal to 1 by 2, so it will be cancelled out, xp will be equal to square root of dt. Did you get this one? You may ask now. Is it okay? If different location and different times are given, so based on this you can solve. Sanjit, is it okay? I have already solved this question in previous classes, so can you try? I think you will get this in Callister. You can go and try one or two questions from there. Okay. Have you read this question? Yes, it will be nearly 20. So see, a copper alloy powder had an apparent density. Apparent density is given. Apparent density means powder in loose form, and tap density means after tapping it is 4500 kg per meter. Then powder is compacted in a cylindrical die at 300 megapascal. Means after compaction. After compaction we call it green density. It is 6000 kg per meter. Subsequently, the compact is sintered. After that it is sintered. After sintering, the density is 7500 kg per meter. And theoretical density it is given 9000 kg per meter. So if the powder is compressed to 10 mm height, means powder was in loose form. Suppose this is cylindrical die and powder is filled till height h. Suppose this side it is H. The theoretical density of the if the powder is compressed to 10 mm means after green density. This side suppose it is H1 and this is apparent density. So we know it mass of the powder will be constant. M1 suppose this is M1 and this is M2. So M1 will be equal to M2 and we know rho equal to density mass by volume. So density in this case what if we assume rho 1 rho AD we have already assumed rho AD means apparent density will be equal to volume of the powder. Suppose it is V1, this is green density and suppose it is V2. So can you solve now? Is it okay, Achanta? And it is given like 3000 and volume of powder. So what will be the volume? Can you tell me what is the volume if we assume cylindrical form? Pi d square by 4 into, yes, height is h1 and rho g is 6000 it is given. Pi d square by 4 diameter will be the same in both cases but this powder height will be reduced. Suppose it is h1 so it will be cancelled out and it is given if the powder is compressed to 10 mm height. So h1 value is given, this is 10. So h value, this value, fill height will be 6000 into 10 by 3000. So it will be 228. Is it okay? The densification parameter. Do you know what is densification parameter? It is like green density minus apparent density divided by theoretical density minus apparent density. So if all values are given, so if you put, you will get 0.5. Densification parameter means it is the ratio of the difference between green density minus apparent density and theoretical density minus apparent density. This is called densification parameter. It is just for measurement purpose. You can note down this equation. In powder metallurgy book, I have forgotten the name. You can go further. Is it okay? Can you solve this question? What will be the elastic modulus of composite parallel to fiber direction? Okay. Is it okay? This question is important. Like both are same data. Let me add. 46.2, yes. And second part, like this is like isostrain condition. So you try first. Isostrain condition means it is longitudinal direction, we can say fiber direction. So here strain will be equal, strain in composite, strain in fiber, and strain in matrix, it will be the same. So can you try? This is isostrain condition. Here polyester matrix composite is unidirectionally reinforced with 60 volume percent of e-glass fiber, means V F value is given 60 volume fraction of fiber, 60 volume percent. So we can write 0.6, and for matrix it is 0.4. Yes, 94. It is, what was it? Yes, yes, 94. So EF value is given 72.4 gigapascal, and for matrix EM matrix it is given 6.9 gigapascal. So we know for E composite, when it is parallel to fiber direction or along fiber direction, we can say EF into volume fraction of fiber plus EM elastic moduli of matrix into volume fraction of matrix. So 1 minus F. So simply if we put the value, we will get E composite. So can you tell me what is the value? EF 72.4 into 0.6 plus 6.9 into 0.4. So what will be this value? E composite, it will come nearly 46.2 gigapascal. And if this question will be like it is parallel to, if it is asking in transverse direction, so E composite, can you tell me what is E composite in transverse direction? Isostasis condition. Can you tell me? Sanjeet. Okay, okay. Here states will be the same, isostasis condition. I have already proved this equation in previous classes. You can go and check Callister. You will find. Okay. So E composite will be like 1 by E composite 1 minus F, volume fraction of matrix by E matrix plus fiber by E F. So if you put value from here, you can calculate EC in this condition. Right now it is not needed. Once. if the load of 100 kg is applied on the composite in the fiber direction, the load carried by the fiber in kg, it is isostress condition. So we know load composite will be equal to load in fiber plus load in matrix, and it is 100 kg. And this is isostrain condition because parallel to loading direction, the fiber direction. So epsilon C composite will be equal to epsilon M equal to epsilon F. Strain in composite, strain in matrix, strain in fiber. And we know from Hooke's law, elastic modeling equal to stress into strain. So from here, you can write down E M by sigma F equal to EF by sigma F. So sigma F by sigma M. And you know EF value is here 72.4 divided by 6.9 EM. So if you solve, you will get 10.4927. And this value we know, this is FF force by area, this is stress, and this for sigma M it will be AM by FM. So it will be equal to 10.4927, and here's FF by FM, we can write down 10.4927 into AF by AM, and we can make it like F by AM. What we can do, we will make it in volume because volume percentage given. So a composite, if we divide both in AF and AM, same value we will get, and we will multiply LF by LC because strain is same. So this value, and this value, it will be the same. So we can write VF, volume of fiber by volume of composite, total volume we can say, volume of matrix by volume of composite. This is fiber volume fraction, and this is matrix volume fraction. So in place of this, we can write down this one, 10.4927. F value fraction, fiber volume fraction is given 0.6, and 1 minus 0.6, it will be 0.4. So F value will be equal to 15.739 FM. So we know this equation, and already we know F from here. In equation it is given FC is equal to FM plus FF, matrix fiber, it is 100. So simply you put 739 FM plus FM equal to 100. So if you take FM common, you will get 100 divided by 1 plus 16.739. So if you divide you will get 739 5.97 kg. So we know this Fm means load carried by matrix, and it is asking load by fiber. So just we will subtract 100 minus 5.97. It will come nearly 94.025, nearly 94 kg. Are you getting, Sanjit? Sanjit, you can try for this. This was isostatic condition. You can try for isostatic condition, where stress will be equal. I have solved for isostatic. That's why I have taken this one. Is it okay? Okay, let us solve this one. Can you tell me what is eutectic? Okay, eutectic. Eutectic means yes. So option 2 will be right. For eutectic, L it is forming eutectic reaction. Liquid will change to solid. What about this eutectoid? Yes, for eutectoid, one solid it will become two different solid. S2, suppose it is S3. So eutectic this one, eutectoid this one, and peritectoid. No, no, it is not peritectic. It is peritectoid. In peritectic, okay, yes, S1 plus S2, S3 means it is S1 plus S2. Yes, this one will be plus. And in peritectic, we know liquid plus alpha, it will become like two different, like liquid plus solid. And for monotectic, like one solid, it will change to, it is actually monotectic, yes. One liquid, it will change to solid plus another liquid. So this is this one. And what is monotectoid? Alpha, suppose it change to one solid to other solid with different composition, and plus this is beta. Is it okay? See, in eutectoid, here we get two solid but with different composition, like two different solid we get. But in monotectoid, if you observe this alpha, we are getting like same solid but different composition. Like suppose this is alpha phase and it got precipitated in beta. So this alpha amount, it will suppose in alpha there will be some aluminum uh, content. So in alpha dash you will get different aluminum content. Are you getting? Phase will be the same. Huh. Yes, yes. You please also you see you in Kalisha it is given. Yes, you are saying right. TV Rajan, do you have book TV Rajan? Heat treatment. You can go for this also. So whatever questions will be asked based on this six equations. There is also one syntactic. Here two liquid, it will convert into one solid. Okay, you try for this question also. After that we will be. Okay. I have taken screenshots. That's why it is not very. This is this is important. From Bragg's law, we know like lambda equal to 2d sin theta. So you just put the all value. Interplanar spacing, this is d interplanar spacing. You will get nearly 0.158 nanometer. So can you tell me what is the Miller indices of the reflecting plane? Yes. Why? Yes. So if you put the value, okay, A value and D value, A value is given 0.316 and D value we are getting 0.158. So it will be 2. So if we take h square plus k square plus l square value, it will be 4. And it is FCC given. So it will be like 3, 4, 3, 4 and 8, 11. Is it right? Can you check? 3, 4, 7 is there or not? You please check this one. So this is 4. So we know this is 4 for 4. So possible Miller indices will be 2, 0, 0, 0, 2, 0, 0, 0, 2. So here option B is the correct option. Okay, then do you have any problem in previous questions? You may ask. Otherwise, we'll meet next week. Okay. Okay then. Thank you.